Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 284. Please turn to page 284. Today's our lesson number 138. We are going to do problem number 108 and 109. We'll do 109 first. Let's get it out of the way first. In problem number 109, we are told that we have a list M, which is not given to us. We are told that that list consists of 8 different integers. We are also told that each one of which is also present in the list below, which we are calling list L. In the book, they do not give it a name. Let's call it list L. And the list L consists of these 10 numbers, all the even numbers starting from 4 ending with 22. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I left a space in between. It has no significance. I just left it there so it's easier to count. There are 10 of them. The question simply is, what is the standard deviation of the numbers in list M? What is standard deviation is the very first question we need to ask ourselves. The standard deviation is simply the measure of spread. Standard deviation is so called because it tells us how much each observation deviates from the norm being the average, the mean. Well, we know the average. They tell us that, actually they don't even tell us the average. They tell you nothing at all. All we know is that we have 8 numbers and all of those 8 numbers are present in this list. We do not know which 2 numbers to drop here. There are 10 of them here. We do not know which 2 numbers do not belong in the list M, and therefore since we do not know which 2 numbers to drop, we don't even know their average. So anyway, in order to figure out the standard deviation, we need 2 pieces of information. Okay, listen carefully. We need 2 pieces of information. We need to know, actually only one piece now that I think about it. In order to figure out the standard deviation, we need to know the entries. We know the exact entries of each of the numbers, the way this is set up. Once we know the entries, once we know each of the entries, we can figure out the average. Once we have their average, we can ask ourselves how much does each observation deviate from the mean. And that's what standard deviation is. We don't have to worry about right now. We don't have to worry about what the exact formula is for the standard deviation. If you do not know how to actually calculate the standard deviation, don't worry about it. The point here is that the only way we can figure out the standard deviation is we have to know what those 8 numbers are in the list. Let's see what they tell us. In the first piece of information, they tell us, in the first statement, they tell us that the average of L equals the average of M. When I say average of M, I mean the average of numbers that appear in list M. I don't want to write all of that out. So average of all the numbers that appears in list L equals the average of all the numbers that appear in the list M. What does that tell us? Let's find out. Let's find out what average of the L is, which is given to us here, right here, the list L. List L is 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. Now, in order to figure out the average of these 10 numbers, we don't actually have to waste our time to sit there and add them all up and divide by the number of numbers. We don't have to do any of this. What we have to realize is that because these numbers are evenly spaced, the fact that they are all even numbers is not the point here. Even if they were spaced by three figures, for example, had it been 4, 7, 10, as long as the difference is constant, as long as they are evenly spaced, as long as the numbers are evenly spaced. For example, the average of 3, 13, 23, 33, and 43, because these numbers are evenly spaced, 13, 23, 33, 43, they all always go up by 10. As long as they are evenly spaced, the average is the middle number. That's all. And if you happen to have even number of numbers, instead of 5 numbers, if you only had 4 numbers, then the average of these 4 numbers would have been the average of these 2 in the middle. In other words, if we go 5 from here and 5 from there, that's 18. The average would have been 18. And if you don't believe me, just do it out. If you add up all of these 4 numbers and divide by 4, you will find that the average of these 4 numbers, 3, 13, 23, and 33, is 18, which is the number falls right in the middle, which is what we have to do here. Figuring out the average of these 10 numbers is very simple. It's just the number in the middle which is 13. 13 is the average of the number that appeared in the list L. And they're telling us that the two averages are equal. Average of number that appears in list M is the same as the average of the average of the number that appear in list L. And we just found out that that is 13. Now what does that tell us? What does it tell us? Let's find out what it tells us. Since the average is 13, what we find, well, the part that we are about to do, actually we could have figured out without the average here. What we understand here is that the sum of numbers in list L, there are two ways we could have figured out the sum, which is one way is to actually add them all up because we know all the numbers, but that will take some time. But now that we know the average is 13 and there are 10 of them, their sum is 13 times 10, or 130. Since the other list has 8 numbers, the list M consists of 8 numbers and it has the same average, this implies that the sum of numbers in list M must equal 8 times 13, or 13 times 8 if you like. 13 times 8, because the average is 8 and there are 8 of the average is 13 and there are 8 of them. 13 times 8 is just 2 13s less than the other guy. These are 10 13s, these are 8 13s, so it's just 2 13s left. 2 13s are 26. So you just subtract 26 from here and that's their sum. The sum of the numbers in list L is 104. The question is, and the difference, as we can see there, is exactly 26. The difference is 26. What that tells us is that now we know that we need to drop two numbers that add up to 26. Because that's their difference, 130 versus 104, because the average is the same. The question is which two number to drop. This one has 10 numbers in it, list L has 10 numbers in, list M has 8 numbers. We need to drop two numbers. The question is which two? Let's find out. Okay, watch what happens. Here is the list L. 4, 6, 8, 10, 12. 14, 16, 18, 20 and 22. Which two number do we drop? Had there been simply one possible scenario where two numbers add up to 26 in this list, then we would know which two numbers would drop, because the two numbers that we need to drop have to add up to 26. But unfortunately here, more than one scenario are present where the sum of the two numbers will be 26. For example, do we drop these two numbers? 12 and 14 add up to 26. Do we drop those two? Or do we drop these two? 10 and 16 add up to 26. Or do we drop these two? 8 and 18 add up to 26. Or do we drop these two? 6 and 20 add up to 26. Or do we drop these two? 4 and 26. Which pair do we drop? We do not know which pair to drop. And without actually knowing which pair to drop, we do not know which 8 numbers we are dealing with, and unless we know the exact 8 numbers that we are dealing with in a list, we cannot figure out its standard deviation. Therefore, the first statement is not enough. First statement is not enough. Statement 1 is not enough by itself. A, D, B, C, D. Since the first statement by itself is not enough, the answer cannot be A or D. Now, the information in statement 1 was not worthless, it wasn't completely useless, it's just that it is not sufficient. It was actually very valuable information. Now we know that the average of the two lists is the same, which is very helpful information. So now we know that the sum of the numbers in the shorter list, the list M, which has 8 numbers, it has the same average as the other list, which means it's got to be 8 times 13. We need to drop two numbers which are close to 26, which is very useful information. But it's not enough. We don't know which two to drop. Let's see what the statement number 2 says. The statement number 2 tells us that list M does not have 22. List M does not have 22. Is that enough by itself? This statement, statement number 2, by itself does no good. By itself it does no good. Simply knowing that the list does not have 22 in it, it does not tell us which other number we're going to drop, because we know nothing at all about the list. So by itself is no good. But when we put them together, now we are done. We have our dilemma, which pair to drop, because they come in pair. They have to add up to 26. We can't just take 2, 1. We cannot simply take 6. We cannot take 6 and 14. That's not going to add up to 26. We cannot take 10 and 22. That's not going to add up to 26. They have to add up to 26. Whichever two numbers that we drop, they must add up to 26. Now they tell us that 22 does not belong in it. And with the information from the first statement, we know that this is a scenario we're dealing with. The pair that we need to drop is this one, 4 and 22. Those two numbers do not belong in the list. If the 22 does not belong in the list, neither does the 4, because we need to figure out another number that will add up to 26. Once you drop 22, we must drop 4, because they have to add up to 26. Now we have our list. If we have our list, we can figure out the standard deviation. Voila, that's it. So putting them together does the job. By itself it does no good. We need to, so together is okay. The answer is C. The answer is C. But by itself, it is of no use. Let's do the next question, which is problem number 108, which is the most straightforward, simple problem. Actually, because of the fact that it's more straightforward, simple problem, which is why I don't like it, because it's too silly. You'll see what happens in problem number 108 in a second. We need to erase stuff. We need the room. In 108, it's sort of annoying. You will see in a second. Question is, what was the train's speed? What was the train's speed when it had finished half its journey? Whatever you can tell, you can have a gut feeling that we're not going to get anywhere with this problem. The answer is going to turn out to be probably E, because they are looking for at what speed was the train traveling on the trip when he had completed half of the total distance of the trip. They want to know the precise speed of the train, at the precise moment when it reached half his destination, half his journey rather. However long the journey was, when it finished precisely half the distance, they want to know the speed of the train at that precise moment. You need a lot of information for that. Let's find out what they tell us. Because they're not even looking for the average speed at that point. They're not saying what had been the average speed over the half the course, over half the journey. They're looking for the precise speed at that point. What was the precise speed when the train finished half his journey? In the first statement, they tell us that the trip was 460 miles, and it took 4 hours to complete. What does it tell us? If you put the two pieces together here, it was 460 miles and took 4 hours to complete. What it tells us is the average speed. 460 miles over 4 things. 4 divided by 4 is 1. 4, how many 4s in a 6? 6 has 1 4. The remaining 2 goes and joins the 2, becomes 20, and 20 has 5 4s. So this tells us that the average speed was 55 miles per hour. That was the average speed. But that is not going to tell us the precise speed of the train when it finished exactly half its distance. It's not going to do anything. The first statement by itself is no good. A, D, B, C, D. Because the first statement by itself is no good, the answer cannot be A or D. Let's look at second statement. The second statement goes on to tell us proudly that the train traveled at the average speed of 115 miles per hour. What the hell? It tells us that the average speed was 115 miles per hour, which is exactly what we found from the first statement. If the first statement by itself was of no use, neither is the second statement, because second statement is telling us the exact same information as the first statement did. Therefore, answer cannot be B. Now, ordinarily, we would have put the two statements together to see if we get someplace by putting the two statements together. But here, putting the two statements together is futile, because we're not going to get anywhere. Because the two statements are telling us the exact same thing. Both the statements tell us that the average speed of the train was 115 miles per hour. Putting the two statements together is the duplication of this information. It's not going to get us anywhere. The answer is E. Putting it together is also, as I said, would be an exercise in futility. It's not going to get us anywhere. The answer is E. I will see you tomorrow, okay? Bye now.